In Chapter 7, we're going to be dealing with rational expressions. So let's first define what a rational expression is. When you use the word rational, like a rational number, what we're talking about in mathematics is a fraction, okay? And then when we use the word expression, we're talking about something like 5x plus 2, some combination of numbers and letters together. So when we talk about a rational expression, what we're talking about are fractions with letters and numbers. For example, 5x over 4 is a rational expression. Another rational expression might be 2x plus 7 over 3x minus 1. Or we could do something a little bit more complicated, x squared plus 9 over x squared plus 2x plus 1. Those are all rational expressions. Now, what happens with rational expressions is you'll notice that in two of the examples, we've got variables in the bottom of our expression. We learned in elementary school that we could never divide by 0. So we cannot have a 0 in the bottom of a fraction. So what we're going to look at in 7.1 is something called restrictions. And restrictions are just asking you what number would cause the bottom of a fraction to be 0. Okay, let's go through a few examples. So for our first example, we have 8x squared over 8x minus 8. Now remember, we're only concerned about the bottom of these fractions, and we don't want it to be 0. So what we're going to do is we're going to take the bottom, this 8x minus 8, and we're going to set it equal to 0, because that's what we don't want it to be. And by doing this, we'll figure out what number we can't use in our problem. So we're going to add 8 to both sides, and 8x equals 8. We divide both sides by 8, and x equals 1. So 1 is our restriction. So for our second example, we have negative 2x over x squared minus 7x. And again, we're going to take the bottom of this fraction, set it equal to 0, and now it's just a matter of solving it. Now, unlike the previous example where there was just an x, notice here we've got an x squared. So that means we're going to have to do some form of factoring that we were talking about in Chapter 6. Now, this particular example, notice that both terms have an x in common. So we're going to pull out an x. We're going to have left over x minus 7 equals 0. We're going to take each piece and set it equal to 0. So x equals 0. And x minus 7 equals 0. This first one's already solved for us, so we know that one restriction will be 0. On the second one, we're going to add 7 to both sides, and x equals 7. Now, when you place this into HOX, what you're going to have to do is in that one box they give you, you're going to put 0, 7. And it really doesn't matter which one goes first. Make sure you don't put any spaces between them. So for our third example, we have x plus 8 over x squared minus x minus 20. Again, the first step for finding a restriction is always to set the bottom equal to 0. So we've got x squared minus x minus 20 equal to 0. Again, remember, if you see a squared, that means we're going to have to do some type of factoring. Since this is a trinomial, we're going to factor it into two parentheses. We've got an x and an x. We're going to have positive and negative here. And then two numbers that multiply to 20 and subtract to 1 would be 4 and 5. Since our middle term is negative, that means that our 5 is going to go with our negative, and our 4 will go with our positive, still equal to 0. Now split it up. x plus 4 equals 0. And we're going to subtract 4 from both sides. So x equals negative 4. Here we're going to say x minus 5 equals 0. We're going to add 5 to both sides. So x equals 5. So again, we have two restrictions at negative 4 and positive 5. For our fourth example, we've got x plus 11 over x squared minus 9. Again, taking the bottom of our fraction, setting it equal to 0. We've got an x squared, so that means we're going to factor. And remember, this is called a difference of squares, so it factors into two parentheses. We've got x plus 3, then x minus 3 equals 0. We're going to say x plus 3 equals 0 and x minus 3 equals 0. We'll subtract 3 from both sides on our first equation to get x equals negative 3. And we'll add 3 to both sides here to get x equals a positive 3. There's our two restrictions, x equals negative 3 and x equals positive 3. For our next example, we have 7x minus 1 over x squared plus 1. So again, taking the bottom, set it equal to 0, and then we're going to factor. Now, earlier, the previous example, we had x squared minus 9, and I told you that was a difference of squares, and it factors x plus 3 and x minus 3. Now, you really want to, a lot of people want to think that this one does the same thing because it looks really close to the other one. But you'll notice in this one, instead of saying minus, it says plus. Now, unfortunately, that plus sign in the middle makes a really big difference because at this point, this particular problem is not factorable. Okay, we cannot factor this. So if we can't factor it and they're asking for a restriction, then our answer is going to be no restriction. There are no numbers that cause the bottom of this particular fraction to become 0. So for our last example, I've got x squared plus 25 over 5. So if we take the bottom of this fraction, we come over here and we set it equal to 0, you'll notice we have a problem. We don't have any x's to solve for, and 5 is not equal to 0. So in this particular problem, there are, again, no restrictions. Okay, and we can kind of make it a rule that if there's not a variable on the bottom of our fraction, then there's not a restriction to the problem, or there's no restrictions on the problem, because there has to be a letter there in order for you to make something turn to 0. So there are only two steps to finding a restriction. The first one is you want to set the bottom of the fraction equal to 0. Okay, and then the second step is to solve. Now obviously that's a pretty big step. If there's just an x, then you're going to solve it by moving the variable or the numbers around. If there's an x squared, remember you do have to factor some form, whether it has something in common or you're going to factor it into two parentheses.